Hello everybody, and welcome back to the Wuffenberg YouTube channel about time bomb amplifiers, the one consisting only out of pentodes, even in the preamp section. And there were already one or two videos about this body here and the history of the chassis. So now let's today look a bit about the progress that was done so far, that we had so far. So the front design is more or less clear now. So, look, we will start here on this side. We have this the on-off switch, and it will still get this nice military grade protection just to make it look nice. At the moment you see I mounted this protection here, so it does not really fit. That's why I just took it off, but in the final design it will be there. Then under it will be the selector for the rectifier selector, so we can choose between valve rectification and bridge rectifier. This is pilot lamp. Then from the big controls, this one will be master volume, and as you hear the click, this is where I usually connect then the standby functionality as well, so master volume. Then this one will be the mid settings, and for this amplifier I will call it the scoop, because I found out that this mid is really quite important for the sound, while the smaller buttons here, which will represent the bass and the treble settings, are usually not changed so much during the design, but with the scoop you can really define pretty much the sound from the scoop mids to the full mid range. And I like this functionality, and since I don't have any spot here where I could fit 3 pots in a row, I just make it a dominant part of this amplifier. So it's really scooping. The gain is then here. This one is the input jack. This one will be speaker output. And very interestingly, and probably a change or difference to other amplifiers, is this switch here. This is a 3-fold switch to change the output impedance from 4 to 8 to 16 ohms, because I'm not using negative feedback loops in my amplifiers. So I found out that the connected impedance and the way the impedance selector is set on the amplifier really makes a big difference in the sound. Almost a bit hard to predict how the sound will develop with different output impedances, but I found out that that if the speaker impedance is somewhat lower than the setting on the amp, the sound gets more scooped and more heavy and more aggressive. And of course, for me as a heavy metal, thrash metal guitar player, this is pretty much preferable. So for instance, if I would set this one to 16 ohms and connect to 8 ohm cabinet, the sound really gets some extra, how to say, I don't know, something extra buff. Alright, then let's turn the whole thing. Oh yeah, and this one will be spot where the magic eye will fit. In the last video we saw that I drilled it, and here now we see that there is some, let me just zoom it in, my little mistake. Yeah, you see that some color unfortunately went off, but I mean, this is something I can correct later on with some separate paint. Then let's turn the whole design, and we can take a look inside what has happened so far. And compared to the last video, it's already getting quite crowded in the amplifier. So maybe I just start from right to left. Explain a bit. One, pretty straightforward. The input jack, then going through this cable is in the way to show something. I just used a capacitor here just to make sure there's no DC on this input jack and I don't get zapped, even if something in the design would mess up. So then coming to the first PCB board here, underneath we would have there are 2 EF86 tubes inside. Let me first switch off the mains. Unit goes through a separation transformer. I don't want any unpleasant surprises. So we have the first input tube here, the second input tube here. The circuitry will be published in a separate schematic. Not much. Yeah, well, one thing is of course special. I use a separate screen. How to say, screen voltage or screen voltage supply. Can be seen here. Actually, what I'm doing is I'm feeding the main supply voltage through a chain of resistors, which you can see here. So it's like a divider, and I can then have different taps where I could take the screen voltage. So here we have something like I think it was 180 to 200 volts. Here it would be 140. Here something like 100, and here 80 volts. And the ground is, as far as I remember, connected here. So I have the choice of changing the screen supply voltage, the screen voltage. This pink cable indicates the screens on the tubes. So coming back then to the design. And so, since still this is something which is on the experimental stage, you see once again a loose cable here. This is connecting the screen of tube 1 to tube 2, and I found out that they are very sensitive to any kind of interference. I mean, the screen is something like a second grid in the tube, and you need to be careful that this is filtered properly. And at the moment I cannot even see if I put a capacitor here. Oh yeah, I put a capacitor there, a filter capacitor. Yeah, that's the body here. Alright, yeah, so then first tube, then there's some sort of interstage divider. No, sorry, from the first tube we are going straight to the gain pot, which is here, bridged with a little bright cap. From there we make our way to the second tube. Once again, I have these, you see here this blue thing, this blue trimmer, and also here another trimmer, which are meant for the cathode bias. So I'm always trying to find out a good operating point for the tubes with these trimmers, and later they will probably be changed into a fixed resistance. Oops, my tripod is shaking. Yeah, and then another interstage divider is right here, where we attenuate the signal, and later I will show some oscilloscope measurements where we can probably see the division factor is something like 3 to 1, if I recall correctly. Then we're feeding also this yellow is always in my designs, it means always it's a signal path. Red, by the way, is always the anodes, the plates, and this twisted cable here is the heater. Yeah, by the way, the heater for the tubes, at least for the preamp tubes, I converted to DC to make sure we don't have any hum. The filtering is not yet correct so much, because you see I have a flying capacitor here, 3300 microfarad. So this needs to be mounted, and I also want to check a bit how many capacitors I would need, but also be careful not to overload the bridge rectifier, because the larger the capacitors are, the higher the current is. I mounted the rectifier, and this cannot be seen right now. I mounted let me just turn it, oops. I mounted the bridge rectifier here straightly on the chassis to make sure it gets cooled properly. This is supplying then something like 1 amp for the preamp tubes, but due to the rectification and the additional capacitors, filter capacitors there, the power which this bridge rectifier has to deliver, or the current, might even go higher to 3-4 amps. I made a calculation about that. So yeah, we were stopped with this yellow signal, which is with this yellow cable, which is once again the signal. It goes then into the third tube, also a EF86. Once again a bias pot, and from there, well, from there I had no more EF86. But anyway, I just wanted to experiment with a bit with the other tubes. So this socket will be prepared. It's not yet prepared, but it will be prepared for either this one, the EF184, which has basically the same pin out like the EF80. These are also pentodes. They have a very high transconductance of more than 10, so I'm really surprised to see what's happening. They have roughly 3 to 4 times higher current than a EF86, so they are meant rather for video amplification or IF interfrequency amplification in videos, in televisions. But still, I mean, why not experimenting with it? So the fourth tube will be this EF80 or EF184, which are almost the same. I think the transconductance on the 184 is a bit higher. So anything else to say right now? Yeah, from the impedance selector, and then my tone controls are not connected so far. I was a bit lazy in the past days, but I was also had to go to hospital for a few days, which was not so pleasant. So anyway, I didn't have time to work on this one. So these 3 tone pots, tone stacks shall be wired today. And then from the, as I said, from the third input tube, preamp tube, the EF86, at the moment we go straightly to the master volume, and from the master volume we feed then this long tail phase inverter here. The long tail phase inverter, which are the integrated triodes in the ECL82. I hope now this is right, but it should be ECL82, yeah. So, some more main filter capacitors here. As I said before, this is a choke which I put into the design, and as you saw in the previous video, I also had to add another transformer to supply all the filament voltage to the preamp tubes. So let me then maybe connect my guitar and also the oscilloscope to show you what's happening so far. So I'll stop the video for a minute. Okay, so cables are put. I also added the guitar cable and the cable to my 4x12 cabinet. Now let's flip the main switch. You see on the left the anode voltage, or plate voltage, is coming up. At the moment we are in the tube rectifier mode, and just for test I would switch to the bridge rectifier. Okay, this gets 30 volts more. We'll see the input, the effect then shortly. Okay, so with 3 tubes we have already quite a decent amount of gain. Not enough, of course, for me, but let's have a look at the signals. To get my guitar. So, and all those people who saw already my previous videos, they know that I really like to riff in metal style. So what do we see now? I should first explain about the signals which we are getting on the oscilloscope. It's basically all about the third tube. So the upper probe is connected to the input of the EF86, and the output, the lower probe is connected to the output straight before the master volume. And now take a look. Unfortunately, I have some reflections in the screen. Maybe I can, yeah, but it's just as good as it gets. So, haha, you see my guitar is reflecting here. Yeah. So the volume is set to pretty low, but it doesn't matter. It's about the signals. So the first, all these, by the way, these probe heads have a divider 10 by 1, 10 to 1, so all signals are attenuated. So the input of the EF86 is not really a symmetrical signal, but it sounds good. And I said this already in previous videos before, that not necessarily a balanced operating point is sounding good, but imbalanced, either too hot or too cold, coldly biased tubes sound better. I mean, just from looking at the signal, where we see that the upper part is clipped while the lower part is not clipped, as an engineer I would say this is not really a good way of operating, but on the other hand it sounds good. About the voltage, we have 1 plus multiplied by 10, so 10 volts per grid. What happens if I switch on? Yeah, maybe. So we have, let's see, 1, 2, 3, 4, roughly 4, up to 4 grids, 4 to 5 grids, 10 volt. So it's 50 volt coming out of the interstage divider. Before the interstage divider, means behind the second tube, I think it's roughly 150, 160, so it's a full swing. But here we have around 50. You still see some negative effects here, which needs to be dealt. This is this extra curve we see here on the bottom. At the moment I forgot how to describe it. I think it was something like if an overdriven tube gets extra grid current, which then lifts the ground potential. So this is something I need to fight. I think there's still too much input for this poor tube. And then the second one, the divider is set on 50 volts. So roughly we see on the output also a swing of, how much is that now? 50? Yeah, 150 volts. So this tube is really getting maximum, and it's almost a square wave. The sound itself is pretty good already. Remember, we don't have a what's that? It's the tone stack. Ah, a little bit more volume. And if I switch, just to give you an indication of how much the volume would change, if I switch to the silicon rectifier mode, yeah. So let's say from the gain, not too bad. However, I want more, so there will be tube number 4. Second point is that a couple of these resistors and capacitors are still in a quite early design stage, and as I said before, it takes probably 20% time in an amplifier to plan it, and then 30% to build it, but definitely 50% to test out all the settings to make it sound good. And and that is really what makes the amplifier, building high gain guitar amplifiers, quite special. For instance, in my sound right now, I still hear some blocking distortion, even though I was operating with pretty small, for instance, coupling capacitors. Here this one is only a 10 nanofarad coupling between the second and the third, and also between the first and second tube, and also any cathode bypass capacitors are rather small. You see here, for instance, 470 nanofarad. The second one has, if I remember well, no bypass capacitor on the cathode at all, and the third one has a only very small electrolytic capacitor of 1 or 2 microfarads. But nevertheless, these are things which are then going in the experimental phase, and right now this was what I wanted to share with you. So thanks for checking. Leave some comments, or leave for all these registered YouTube users, leave a like if you liked my video. Yeah, you can also subscribe. I mean, I really hate these people who are pushing their channel just to get a lot of people subscribing to them, and having this big advertising on the screen like subscribe and blah blah. So if you like it, subscribe. If you don't like it, then of course not. Anyway, thanks very much for watching, and watch out for the next videos. Thanks. Goodbye.